Okay, so can you hear me?
Yes.
Okay, thank you. So let's start by the DS frames and DS parameters for the robot modeling. Okay, I just give you some example, right? Before we continue, I mean with the slide, I want to give you one more say exercise. Okay, one more exercise. Okay. Yeah, one more to review exercise, right? To make sure that you can understand what we did yesterday. Okay, so let's start by this is the robot. Right? It's the robot. This is just a perpendicular, right? Perpendicular. Okay, and this is not the joint, and here the joint. Here the joint. This is the joint. Okay, this is the joint. Okay, I have this robot. Okay, you understand what it is robot, right? You understand what it is robot, right? With the joint. Okay, so this robot have how many degree of freedom? How many degree of freedom in this robot? How many degree of freedom this robot?
4.
4. One rotation here, one rotation here, right? One rotation here, and one is sliding here. Okay. Yeah, so we have 4 degree of freedom. So now can you do the DS frame? Okay. Yeah, let's do together. This I said it one is 0. Yeah. This is 0. And this should be this is 1, right? We don't know exactly what is the point, but we just say yeah, this is 1, this is 2, right? And this is 3. And I also want this in this case. And you know is for the robot, we always want the end effector. The Z4 is the approach direction, as I mentioned. So usually always we do like that. We need for Z4. Okay. So in this case, of course, if I choose here, this is X0, right? If I choose that, so this should be Y0, right? And if you choose this X0 here, then Y0 should be here. Okay. So how you choose S1, X1, YX1? S1 should be perpendicular to Z1 and Z0, and it should if they are G01 and G0 are intersects, so they should be X1 should go to the also go through the intersect point. Okay, so where is YX1? You remember this one can be longer, right? Okay. So where is here X1 here or X1 here? The first case or the second case? Which case? X1 here or X1 here? Can you answer me?
X1 is in the point rotation.
No, X1 should be here. Okay, so that means, remember, this 0 here, this 1 here, and they cross at this point. So this should be O1, right? Remember, the intersect point always the coordinates. Okay, I mean the origin. Okay, so this should be O1 and X1 here. And you also remember S1 is SI should perpendicular and cross or intersects this I minus 1. So of course this is perpendicular and cross and intersect this 0. So it should be here. It cannot be here. Yeah, cannot be here. Remember. Okay. Many of you maybe make a wrong. I mean the definition the frame, and you choose this one here. So in that case, if you make the D8 frame, this length is you disappear on the D8 table. So that is not correct. Okay, yeah, remember. So Act 2, of course, perpendicular to this one and this 2. You can choose any point, but usually you can choose this point. Yeah, you can choose this point, or you can choose any point. Okay, yeah, you can choose this point. Yeah, X2, right? Because they are parallel, then you can choose in any one in the direction. Here also okay, any point, any position, right? Okay, and X3 perpendicular and cross this 2 and this 3. This 2 here, yes 3 here. X2 should be here. Can I put X2 here? Can I put X3 here? Can I put X3 here? Can I put X3 at this point? No. It should cross, intersect these 2, right? Intersect these 2. So only one way X3 here. Okay. Okay. So now is X4. X4 you can choose here or you can choose here is okay. And of course, in this case, it's easy for us to choose X4 here. Okay. You can see X4 perpendicular and intersect X3. Okay. So that is the DS frame. Any question about this one? Any question? Something you are not clear why I choose the coordinate like that? Okay. If no, so I assume that you understand on. Now, can you make the D8 frame? D8 frame, DD1, DD2, DD3, yeah. 1, 2, 3, 4. Okay. DC A, alpha, D, theta. Okay. So can you help me to put the parameter in this table? What is A1? What is A1? A1 is the distance between G0 and G1. And G0 and G1, I should put some parameter here, right? So I should put here L1 here. Just say, or this is L1 or say L0 or L1, just L1 here. This is L1, just say L11 or say L1S. Okay. L1S, that means shoulder, like the shoulder, the shoulder of the arm. Okay. And this is L2. This is L3. Yeah. And D from here to here, D4. D4 from here to here. Right? Okay. So can you put the parameter inside this table? What is A1? Please do it. Okay. If not, you cannot. You should do all of this one. You should be able to do all of these things. Okay. So what is A1? What is A1?
L1S.
A1, L1S. So what is A? A1 is the distance between G1 and G0 and G1. So in this case, what is G0 here, G1 here, and they intersect each other. Understand? So in this one, what is A1? 0. You understand? Can you understand?
Yes.
Yeah, okay. What is alpha 1? Alpha 1 is the angles between G0 and G1 when you look from X0. When you look from X0, when you look from X1, yeah, you cannot remember, look from X1, right? Look from XE, right? Look from X1. X1 here, remember, this is something like G0 here. Yeah, you rotate G0 coincident with G1. So what is the angle? Pi over 2. Do you agree? Right? Look from X1. Rotate G0 coincident with G1. Okay? G0 in this direction. Remember, G0 in this direction. Right? You rotate is coincident with G1. Okay? So it's pi over 2. Okay? Yeah. D, the distance between this is O0, this is O0, and this is O1 here. The distance between O0 and O1 when you project O1 on the axis G0. So in fact, this is already on the G0, right? So the distance is L1. Here we say L1, right? L1. Okay, so this will be L1. Okay, yeah. And this is, of course, always, because this is the variable, so this should be theta 1. Okay, and what is theta 1 in this case? What is the current value? What is the current value? What is the current value of theta 1? What is the current value? Theta 1 is variable. Yeah, theta 1 is variable. And what is the current value of theta 1? Theta is the angle. Theta 1 is the angle between x0 and x1. When you look from G0, then you rotate x0 to be coincident with x1. x1 here, x1 in this direction, x1 in this direction. You rotate this one coincident with this one. So now the value is pi over 2, right? The value now is pi over 2. Okay, pi over 2. Right now is pi over 2. Okay, yeah. Right now is pi over 2. But maybe during the robot operation it will change, right? Because this is variable. Okay, so please do the same with 2, 3, and 4. Okay, A2 is the distance between G2 and G1. So what is this value? What is this value? What is this value?
L1S.
No, I don't think so. The distance between G1 and G2, the distance from here to here. from here to here, not L1S, it's L2, right?
Yes.
L2. Okay. Alpha is the angle between G1 and G2 is 0 now. Yeah, it's always 0 because this is they are always in the same link. Okay, like that. Okay. And what is the D? D2 is the distance. The distance between these two is the distance between O2, say O1 and O2. O1, O1 here, O2 here. Remember this is O2. When you project O2 on this one, when you project O2 on this one, you project here, so it should be at this point. So the distance from here to here is what is that? L what? L1S. Okay, you project O2 on this one, and the distance from O1 to this point is L1S, and is positive in the positive. If you choose X1 in this direction, so it's negative. Okay, so remember the value in this table can be positive or negative, depend on the direction of the axis. Okay, yeah, and this is of course theta 2. And what is the value of theta 2 now? Theta 2 is the distance, the angle between this 2 and this 1. This 2 here, this 1, where is this 1? This 1, so they are parallel now. They are, so this is 0. Yeah. Now it's here 0. Okay. Do the same with the third coordinate. Okay. The coordinate 3. So look at here. A3 is the distance between these 3 and these 2. So what is the distance? L3. Remember, if I choose L3, X3 in this direction, if I choose X3 in pointing down, then this should be minus. Okay, remember, right? Remember, okay, yeah. So that also remember we should follow the direction of the axis. Okay, alpha is the angles between Z3, Z2, and Z3 when you look from X3. So when you look from X3, you rotate Z2 to be coincident with Z3. So the angle is pi over 2. You can check. All right. D is the distance between O2 and O3. O3 here, right? Yeah. When you project them on the G3, so and on G2 here, G2 here. So O2, O3 you project to G2, so they are coincident with O2. So it should be 0. Yeah, and this is of course theta 3. Yeah, this also variable. Of course, this also variable. Variable. And what is the value of theta 3 now? X3 here, X2 here. So you look from this 2. Look from this 2. You rotate X2 to be coincident with X3. So it's also pi over 2. Right now it's a pi over 2. The value now is pi over 2. But remember, this is variable. It will change later. Okay. But at this configuration, it's like this one. Okay. The last one, A3, A4 is the distance between Z3 and Z4, and they are coincident. So it should be 0. Right. And alpha is the angle between them. They are 0. Right. D is the distance between O3 and O4 on the axis Z3. So Z3 here, so O3 here, O4 here, so it should be D4. And you remember I mentioned for the sliding joint, this always the variable, right? Yeah. And theta 3, theta 4 is the distance of Z3, the angle between Z3 and Z4, and they are coincident and always 0 because this is slide, moving slide, and they always the same. Okay. So that's it all. That's it all. So can you understand? Can you understand?
Yes.
I have a question.
Yeah.
Like the z coordinate, it's always is the motion of the arm, right?
What yeast? Yeah, the yeast. Yeah, the yeast acid always the acid of the joint. And what is the acid of the joint? If the rotation joint, I mean the revolute joint, that is the acid of the rotation. Okay. Yeah, and if that is the sliding or prismatic joint, so that is the sliding direction. That is the yeast axis. Okay, onward. Yeah, onward. Okay, so that's why we should define the yeast axis first, then the x axis. Okay, yeah.
So can you show me again about the Z1 and Z2?
I will do another example. Okay, I will do another example. Okay, yeah.
Right.
I will do another example. Right. Well, right there. Right. Okay. I will do another example. And I choose a more difficult one. Okay. Yeah. I will do another example. Sorry, not this one. This is the frown. Okay. Sorry. Did you? Okay, just go like that. Okay. I should put. Don't ask me. I just plot any. Okay. I just plot any direction, so don't worry. Don't ask me. So what is this robot? Right? I just want to. Okay, this robot. So you understand what is this robot, right? So this is right angle. Okay. Yeah. That's so, but that is not the the joy. Okay. So how many degree of freedom of this robot? How many degree of freedom of this robot? How many joy? One. This answer is joy, right? Two. This answer is joy. Three. Wow, it's much more difficult, right? This is 4. And this is 5. Okay? Do you agree? They have 5 degree of freedom. Okay? Yeah. Okay. Then the yeast acid, we always put here yeast 0, right? The rotation acid is this one because this is the rotation joint. Okay, and rotation. I mean pointing out. Remember, when I plot like this, that means pointing out. Okay. If you want pointing in, you can use pointing in. Okay. So this is yeast 1. Okay. Yeah. And yeast 2, of course, the same here, the same parallel. Okay. This is yeast 2. Yeah. And this is, because this is sliding, so this direction on way. Yeah. So this is yeast 3. And this is the revolute joint. This is yeast 4. Okay. And I always want this one is also the gist 5. I want to do like that. Okay.
Yeah, I understand now. Yes.
Now please finish with the X. So the X, of course, you can choose arbitrary G0. If I choose X0 here, then you know where this should be Y0, as I mentioned, right? Should be, you should write right-hand rules, okay? Yeah. Then X1 perpendicular to G0 and G1, and if there's some intersect, they should cross the intersects, okay? So in this case, G0 here, G1 here, so this should be X1. Okay. If you choose X1 in this direction, it's also okay. Yeah. So why not? Why not? Okay. Cancel. Cancel this one. I choose this is X1. Okay. I make this a little bit more complicated. Okay. Yeah. If I choose X1 like that, and okay, this one, right? This one I also choose like this one. This is X2. Okay, I can choose in any direction. Okay, yeah, and of course three here. Then okay, so how can you choose 3 here? How can you choose? How can you choose where should be is where should be I mean X3 or O3. Remember, X3 should perpendicular and cross these 2. So you choose here. If you choose here, is not correct. Then you should remember here, right? The cross here then should be, this should be X3. Of course, you can choose in this direction if you want. Yeah, but in the previous case, I choose this direction because I want to make something, I mean, strange for you. Yeah, and but usually we don't use like that one, but we use it's better in this direction, because usually from the right side it's better for us to determine, I mean, to determine the angles or something like that. Okay, so this should be X3 and this should be O3. O3, remember, right? Don't put here, okay? So yeast 3, yeast 4, of course, X4 you can choose here. X4, right? And where is the of course O4 here? Where is X5? Where is X5? If I already put the yeast 5 here, so remember X5 should perpendicular and cut. That means and intersect or cross the intersect point of G4 and G5. So you cannot put it here, but you should put here, right? Then you should choose here also. This is X5. So in this case, O4 and O5, you should choose a coincident. Okay, like that. So you understand? Okay. Remember like that, the rule like that. Okay, yeah. And of course, from this one you can, but I want to give you, one. Wait me a minute. I want to give you the ds, right? Just dt a alpha d theta. I want you to this is something. I want you to do at only at one line. So what is how about two? How about two? So is it two, right? So two. So what is A2? A2 is the distance. A2 is the distance between this one and this two. So A2 is from here to here. The distance between this one and this is A2. And A2 in this case, opposite, they are opposite direction to these two. So in this case, it should be minus. If I choose this one is L2. So A2 should be minus L2. Remember that. You remember when we move from the coordinate 1 to coordinate 2, right? Then we move along these two. And in this case, we move in the negative direction. So it should be minus L2. That's why, as I mentioned, usually we don't choose X2 in this one, but we choose X2 in this one. It's easier for us. If we choose X2 in this direction, then this is plus. Okay? Yeah, like that. In this case, alpha is 0, right? D2 also 0 because they are when you reject O2 onto this one, they are coincident with O1. This is 0. Yeah, and this is theta 1. Okay? Theta 1, of course, this is a variable, and you can determine what is the current value. Okay? So you understand this one? Remember, when we move from 1 to 2, from 2 to 3, from 3 to 4, and you check the direction of the axis, and if it's in negative direction, then the value should be minus. Okay? Yeah. Okay. So then we move to the next topic. Okay, as I mentioned, we can based on this one, we can find for t, right? And then we can find the endpoint. Okay, and you know this is just the for general, right? For general, this is sometimes the robot you put. Okay. I just delete on this stop thing. Okay. Yeah. So you know, this is just the generous scenarios of the robots modeling. For example, in the workshop, the robot put it somewhere here, and in the workshop, usually you choose say the 0 or the workshop global coordinate. Imagine you have the big workshop, right? Then you should choose maybe the center of the workshop, either 0 or the global coordinate, or you can choose the corner. The corner of the workshop is the 0 coordinate. Then you put here the robot, you put here the table, you put here the table or something like that. So this table you should refer to a global coordinate here. Okay, so if so in this case, when you want to determine the position of the robot, usually you have here the position of the robot reference to the global. Okay, So so look like this one. Okay, look at here. So usually, for example, we know recap WE, your WE this one, yeah, WE the walk, W stand for the walk or clubber, okay. So and E is either the endpoint, you understand. So if we know that, then of course where you put the robot, you put the robot here is 0, then you also have B, yeah, is a little bit more, you know, as I mentioned, sometimes you put the 0 here, sometimes you put the 0, imagine B somewhere here, B may be somewhere here, B that means the base, you can put there, you can put the B here, the B frame, yeah, the B frame you can put here, and the 0 frame you can put somewhere. Usually this one is I, because the base, usually the base and 0 are the same, okay, like this one. This is the base and the 0 are the same, but in this case, for example, in this case, the 0 here, but the base here, okay, and the base and the 0 are different, okay. So I mean, depend, but usually you choose the base and the 0 the same. So in this case, this is the TB0 is just the unit vector, okay. And of course, this is A or T, T01, T12, T2. This is the, what is this one? This is the transformation from the 0 to the from here to here, to the endpoint. Okay, and you know the endpoint usually the center of the clipper. But you know, at this point, maybe you also attack a tool. You attack a tool here, yeah, and you also need to find from this one, from N to E, right? N to E. Wait a minute. Yeah. Yeah, N to E. E that means endpoint here. That is E is this one. Okay. Okay. Yeah. Let me check. Okay. Okay. Just like that. E that means the endpoint. E that means endpoint. And you know, is sometimes the E and the point and the coordinate. Why I show you like that? Look at this. Look at it. I want you to go. I mean, in the previous case, in the previous case, like this case. Okay, like this case. This is this point is the end point. That means the ON. That means ON. Okay, we have a 5 degree of freedom, that is ON. But this is the E point, the N effector. Okay, so sometimes they are not the same. Understand? So they are not the same. So in this case, to find the N, to find the transformation metric from the global to the endpoint, then you need to have one more coordinate here is T and E, and usually this one T and E is just the translation. Usually is translation. I will show you in this case. I will show you in this case, right? I will show you. So in this case, remember this is phi. This phi here, right? This phi, and if you choose one more coordinate at the endpoint. So this is endpoint. So this one also Z6, they are the same, right? And you also choose this is x6. So the coordinate between the coordinate 5 and the coordinate 6, the coordinate 6 is attached to the endpoint. Usually, they are just the translation, Okay, and in this case we have T 5 6 or T5E or 6. Okay, in this case is equal to, of course, is equal to this is the R. R is no rotation. It is the unit vector, unit matrix, and this is 0, and this is 1. Okay, and what is this one? This is the distance from here, to here. I just call this one is L6. L6 is the distance from here to here, or L5 or something like that. L5 or something like that. Maybe L5. Yeah, the distance from here to here then should be 0, 0, and L5. Yeah, that is just the translation matrix. Okay. Now, okay, let's go back with this one. So in this figure, this figure just show you the very general, the most general case when you put the robot somewhere, okay, and you want to calculate the endpoint reference to the global or the work coordinate. Okay, so that is what I mentioned. Okay, yeah. Then from here you can find the endpoint of the robot reference to the work coordinate by multiply TWE from here to here. TWE is from here to here, right? So it's equal to TWB. Equal to B. Let me so this is B, and so they put this is B already. So we don't need to we already named this is B, right? So in this case we assume that B and 0 are the same. So this one the same. So this should be word, and I mentioned should be word, and this should be like this one, right? TWE equal to TW0, right? Then T0 from here to here. That means T0 end. Okay, from here T0 end. We have n degree freedom. Then T0 end, and I showed you before, and TNE. Okay, TNE. Okay, so that is if the n and the e are the same, then this is TNE, just the unit matrix. Okay, yeah. So that is the general problem. Okay, yeah. We just want in this case, of course, TW0 is known because you put this is somewhere, then it should be the known value. Yeah, and this one also known because you know the length of this one, you know everything here. Only what you should find, to find is a T0n, and T0n equal to what? T0n, as I mentioned before, equal to T01 multiply T1 2 T2 3 or something like that. Okay, yeah. Okay, then let's consider some robot. Okay, with the real robot. Okay, so in this case, this is the SCARA robot. Okay, SCARA robot, right? What did you want? Just delete that. Let's make it okay. Yeah. So I choose DDG0 here. Yeah, rotate about this one. You know why I choose them? Because there are rotation here, the sharp, the sharp of the rotation here. So this is theta 1. Right? Okay. And there is sharp of rotation here, this is theta 2. Okay. And here sliding. There here sliding. Okay, this sliding. Okay. And we have, I choose, in this case, these two I choose up also, right? And at the end point, this is this 4 end point. I always is in this one. Okay. Yeah. So, so in that case, I choose the coordinate like that. Okay. So how can we determine the parameter? I mean the says the DS parameter. Look at here. We have 4 degrees of freedom, right? And just look at the data I give here. From here to here, D1. The distance from here to here, D1. Okay. And from here to here, A1. From here to here, A2. From this sub to this sub, A2. Okay. From this one to the end point, D3. And of course, if you this is just the says the adapter, and you can attack here. You can attack here the gripper. Then the distance from this one to this one is D4. Of course, you can put here the gripper or maybe a tool. Okay, and the distance is D4. Okay, so now G0, G1, G2, G3, G2 and G3 the same, and G4 is the gripper and G4 on. And I mentioned the when you use the gripper or the tool, the final is always the approach direction. Okay, so in this case, what is the X0 is arbitrary. So X1, remember X1 is perpendicular to Z0 and Z1. So this line, okay, this line. So X1 here, okay, X1 here, okay. So X2 is perpendicular to Z1 and Z2. They are parallel, and this is X2. Okay, yeah, and X3, of course, perpendicular to Z2 and Z3. In this case, Z2 and Z3 are the same. Okay, so you can choose X3 arbitrary. In this case, you can choose X3 arbitrary. And why don't you choose the same as X2? Okay, as I mentioned, if possible to choose the parameter the same the previous, then should choose the same. Okay, and G4, as I mentioned, G4 here and X4. Usually, I want to show you a little bit here. I want to show you a little bit here. If this is gripper, maybe I showed you before, gripper, this is this, or we name it A, approach, okay, and Y, and the Y axis is the sliding. For example, if you choose here, sliding, this is Y, and we call this the S. S is sliding, the sliding of the gripper, the sliding, gripper part, okay, yeah, and is perpendicular to this one and this one, so you can use the right hand rules, and in this case we can have you can put right hand rule. So in this case, a little bit, but yeah. So okay, this is okay. I can point in. Huh? for in. This is the x. This is the x, or its the name is n. Yeah, normal. Okay. So usually for a creeper, you should choose like that. Okay, N S A. A is the approach. S is the sliding, and N is the normal. Okay, yeah. So usually like that. Okay, yeah. We then in this case, okay. So in this case, we will have here. This is Act 4, right? If here, I want to delete this one. Okay, yeah. So in this case, this is the if I put the clipper here, if I put the clipper like that, then it should be like this one. The clipper now like this one. Okay, the clipper now like that one. Okay, the clipper. Okay, so the clipper like that. So X is pointing down. Y is sliding. I mean, so you can choose this is X4 here, X4 here, just for pointing down. X4 here, just for pointing down. So in this case, Y is here. Y4, circle direction. Okay, like that. Okay, from right to left. You can check that. Okay, but usually we don't need to assign the Y direction, right? Yeah, you don't need to assign the Y direction. Yeah, like that. That people like that. Okay. Okay. So that is how we can do with the real one. So now we can check the table. A1 is the distance between G0 and G1. So it's A1. A2 distance G1 and G2 is A2, right? And A3 and A4 are 0 because they are coincident. Alpha is the angle, G0 and G1 is 0. G1 and G2 is 0. G2 and G3 is 0. G3 and G4 pi over 2. Sorry, pi. Okay. So Q1, D, the distance between O1 and O0. So D1 here, the distance here, the D1 here, right? Project D1 to here. So D1. Okay. Yeah. And D2 is this one because we choose O2 here. So O2 and O1 are coincident, so it should be 0, right? When you project here, yeah. And D3, the distance between O2 and O3, yeah. If we choose here is O3, and I name is the D3. And in this case, is not. Is the variable. Is a variable, right? Variable. Okay, I put here the red color, that means variable. Okay, yeah. In the D3, right? Yeah. And of course D4, the distance from here to here, they are fixed. Imagine if you put here the tool, so this is the length of the tool. Okay, yeah. And for theta is theta 1. Okay, theta 1. And in this case, we cannot find what is the angle, right? Because we plot it arbitrary, yeah, position. So theta 3, theta 2, okay, always is a variable because this is the revolute joint, okay? And this one is theta 3. Theta 3 in this case, 2 and 3 are the same. So this is 0, okay? And theta 4 is also variables, okay, theta 4. Okay, so that is that is the for the I mean the scalar coordinate. Okay, scalar coordinate. Okay, yeah. So can you do which? Okay, I want to copy this one, right? I want to delete this one. This also another way or another plot. Okay, I just delete this one. Okay, just delete that one. Okay, I just want to use another case. Okay, so so can you for this one also the scalar, but in this case I choose I choose the x0 here, right? That means I just copy from another book, so x0 here, yeah, y0 here, right? Z1 x1 here, z2 x2 here, z2 here, z3 the same, and okay. So in this case, like that. So can you help me to? So you know what it is one, right? So sliding, yeah, sliding this and normal. Okay, I showed you before already. Yeah, I showed this is A approach, and this is S sliding, yeah, and normal, NSA. Okay, the orientation of the n effector is NSA. Remember, right? And this one is equal to orientation vector. Okay, orientation vector of the n effectors. Okay, of the n effector. Okay. Okay. Then can you help me to plot the? I mean. Yeah. Okay. Can you help me to fill in this table? 1, 2, 3, 4, 8, alpha, D, theta. Okay. Can you help me in this case for this one? Can you help me? For A1, the distance between Z0 and Z1, it should be L1, right? Continue with A. A2 is the distance between Z1 and Z2, it should be L2. A3 is the distance between Z2 and Z3, they are coincident, that is 0. Yeah, A4, the distance between Z4 and Z3, they are coincident, so it's 0. Okay, alpha 0 and 1 is 0. 1 and 2 is 0. 2 and 3 is 0. 3 and 4 is a pi. Right? 3 here, 4 here, so it should be pi. Okay. D, the distance between O, this is O and this is O1, right? The distance between this, you project O1 onto E0 and they are coincident with O0, so it should be 0. This one, in this case, you choose 2 here, right? O2 here, O2 and O3 here. O2 and O3 here, the same. Yeah. And then this also 0. You reject this one. O2, you reject O2 on 1, it should be 0. Okay. Then you reject okay, in this case, let me check. In this case, if they put like that, so if they put like this one, so in this case, rotation first, and let me see. In this case, rotation first, right? In this case, you can see rotation first and then sliding. Okay, at this part, at this one, we have the motor to make rotation first and sliding. Okay, so they are different from this case. In the previous case, first is sliding and rotation, and in this case, rotation first and sliding. That's okay, right? So in this case also, this one also we have here. Yeah, this one also 0, right? Because 0, this is 0, right? Okay, in this case 0 because they are the same, and this is the final one is D. The distance is D, right? In this case, D is plus or minus. D, remember, G3 with you in this direction. G3 in this direction. So this is this is O2 and O3 here and O4 here. The distance between O3 and O4 in this one, but you choose G3 in this direction. So in this way, it should be minus. Okay, should be minus. Understand? Yeah, should be minus. Okay, yeah. And of course, this is theta 1 and theta 2, theta 3. Yeah. All of this one is variable. And this one variable. And theta 4 is now x4. X4 and x0 we do a 0. We do the same, so 0. Okay, yeah. So that is the DS parameters in this case. Okay, yeah. Yeah, you can show you can see here, right? I make a note here. Here, it is D4 smaller than 0. Okay, because we choose here G3 here, so D4 should be smaller than 0. Okay, remember, right? Okay. Okay, so that is for this robot. Okay, yeah. You can do for many other robot. And then look at here from this one. You can make the T03 equal to T01, T12, T23 or something like that. Okay, so you can have this one. You can check. Okay, T01. Then you just put this one. Put here. Alpha 1 equal to 0. Alpha A1 equal to A1. D1 equal to D1. Theta 1 equal to Q1 or something like that, right? Then you put that into this one. Then you will have T01. In the same way, we have T12 and T23. Then you multiply them together. Then you will have this one. You can check. You have this one. Yeah, T03 and T34. Like this one, right? T34. Okay, and if you put them together, as I mentioned, we assume that TB0 and T4E equal to I. Again, when I show this, I show you this one. I mentioned if we assume this equal to I, that means the global, and this one is the global also put at the 0. Okay, and the tune n effector also the n effector also the tune. Then we will, in this case, we will have assume this one equal to this one equal to I. Okay, so this also TBA, right? TBE. That means the n effector, the transformation matrix from the global coordinate to the n effectors. Okay, yeah. And of course, when you have this one, you just multiply by the coordinate. Then you can find the this is the final solution, right? You multiply the one, you can have the final solution. Okay, yeah. Okay, so because I just want to show you why we have this one. Okay, so again, this is T04, and you multiply by what? You multiply by, you remember R of the point, RE, R of the endpoint, reference to the 0, or just say reference to the global, equal to what? T global work to E multiplied by RE, right? On the coordinate, of course, RE on the coordinate, the n coordinate. Okay, and or REN, just the n coordinate. And in this case, because n and e are the same, so this is 0, 0, 0, 1. Okay, then when you multiply this one by 0, 0, 0, 1, multiply this one, then multiply here, this is 0, only the n term. So this is the T, right? The T04, or say TW n. Okay, then when you multiply here, so this 0 and only this term exists. So this should be, in this case, this should be x, y, and z coordinate. Okay, yeah, that's why this is this is x, y, and z coordinate. And what is this one? This is the orientation matrix. Okay. So that is just so you can form the matrix. You will know what is the position and what is the orientation matrix. Okay. Yeah. So we do is easier one, right? So this one, of course, you can use G0, G1, G2, and G. In this case, because the planner, so you can choose this one is G3, yeah. But if you don't want, you can choose this one is G3 in this direction, okay. But for the planner, usually we choose like that one. So you can plot is like this, okay. And this is the matrix you can check, right? A, L1, L2, L3. L5 equal to 0 because they are the same. Yeah. D equal to 0 because project here is coincident, project here coincident. It's on the plane, the same plane. And when you project to the x, the z coordinate is 0, right? And the angle is θ1, θ2, θ3. You put this one into this matrix, then you have T01, T12, T23, multiply them together, and then I'm sure you can have the solution like this one. Yeah, you can check L1 equal I mean x of the point P equal to L1 cosine theta 1 plus L2 cosine theta 1 plus theta 2 plus L3 cosine theta 1 plus theta 2 plus theta 3. Okay, so that is what we already learned. And now you can use the D8 approach to get the solution again. Okay. Okay, this is a little bit more complicated, right? So in this case, in fact, this is what I show you already. But okay, now just look at this one. Okay, I want to plot this one. Okay, I delete all of this one, right? Just delete all of this one. I want to use the original figure and explain to you what it is one. Okay, like that. The original one without any. Okay. Okay. Yeah. So let's use this figure. I just show you. Okay. So this is one. Yeah. G0 here. X0 here. And this one here. Okay, so in this case, I choose 0 and 1 are the same. Okay, that's also, as I mentioned, you can choose here or you can choose here. Right, in this case, I choose here. So what is the benefits when you choose here? When you choose Z0 here, 0, I mean the global here, that means when you make the manipulation of the matrix, so there are many zeros appear, and then your work will be, easier. Okay, yeah. Then here, of course, this is just 2 and just 3 in this direction. And I mentioned I always want the in this direction. So in this case, because just 3 in this direction, you cannot choose. You cannot choose any point here because just 2 here. So J2 and J3 they cross each other here. Then they here also should be also O3 also. So O3 and O4 are the same. Yeah, O3 and O2 and O3 are the same, right? So here this one is O2 and O3, the same. Yeah, and here I show O1 and O0 are the same. Okay. So in this case, what is A? A1 is the angle, the distance between Z0 and Z1. They are 0. Okay, and this one is L2, and this one is 0. Okay, alpha angle between G1 and G0. When you look from X0, you look from X1. Sorry, you look from X1. You make the rotation. Right? For G0 coincident with Z1. When you look from X0, so this angle is pi over 2. Okay, yeah. And the second case, Z1 and Z2 is 0. Z2 and Z3, when you look from X3, you rotate Z2 to be coincident with Z3. So it's a minus pi over 2. Okay. And X0, L1, L, I'm sure you will know what is that. And theta 1, theta 2, and theta 3, the angles. Okay. Yeah, for this one you have that, and you just, if you want to find t from 0 to 3, then you can easy to do. Okay. Yeah. Yeah. So in this case, what I okay, like that. They just I want to check some solution. Okay, I want to check some solution. Okay. Okay. Delete that. Delete that. Okay. So this is another one. So only different. In this case, if I choose X0 here, if I choose X0 here, not at this point, but X0 here. So in this case, only different it is one, right? L0 and what EL, why I put here minus? Sorry, why I put here minus here? Here, not minus, should be minus. Why minus? Checks why minus. L1, D1, the distance between between O1 here. What is the Z0? Yeah, Z1 here. Okay, what is let me see. Yeah. Okay. So this one a little bit. You should remember here. Why is minus? Why minus here? Because look at here, we have this is D2, right? D2, the distance between this is O2. O2 and this is O1. O1 here. O1 here. Then you project this one onto the this one. So this is the projection. So the distance from here to here. The distance from here to here. This should be D2. Right? And in this case, from here to here is the opposite direction to this one. So it should be minus L1. Okay, so here also, right? Here also minus. Here also minus. Remember, minus. Okay, yeah, minus. Remember. Okay. So here a little bit wrong, or of course maybe they mix a note somewhere that it should be minor or something like that. Okay, remember. Okay. Okay. Now we go to the next one. Then for example, at this point, then we will put here the gripper. Imagine. We will put here a gripper, okay? Not a gripper, a grist. Okay, a grist. So for the grist, remember we have, they are, as I mentioned, we now when we do the robot, we always choose the history pointing out. Always history pointing out here. Okay, and then you put the gripper here, then the rotation about this one. Always the history always pointing this direction. Okay, and the angle rotation about history we call that is theta 4. Okay, so in this theta 4 in this case is like the joint, right? And theta 4 is perpendicular. G4 is a perpendicular here, right? Peak G4 in this case is like the peak, okay? And G5 like the crown, okay? You know that, okay? And so again, you remember we named this one O3, right? So we put this one O3 here, right? Then, of course, G3, G4, and you know what is X4, Okay, X4 you can put in this direction or you can put in this direction. But in this case, I mean they use the standard. They most of they make is X4 in this direction. Then we follow, and most of the researchers they use X4 in that direction. Of course, you can use X4 in this direction. Okay, yeah, and yeast 5 is rotation about this axis. Yeast 5 here, yeast 4 here, then X5 perpendicular to this one, so X5 in this direction. Okay, yeah, okay, and finally, from here you will put the gripper. Okay, and for the gripper, yeast 6 always in this direction. Okay, yeah, and X6 as I mentioned, X6 and is in the normal, and in this case it's not like this. It's not like this, but it should be like this one, right? If I plot like this one, it should be not like this, but it should be like this one. Yeah, it's like that. Yeah, so in this case, N in this direction, okay, yeast in this direction, okay, and of course Y in the sliding, okay, yeah. So you will have, this is the GRIS D8 say table, okay. Then look at here, 0, 0, 0. You can check because they cross each other, intersect each other, and always 0. Okay, and alpha is like that. You can check by your. Okay, D1, D is the distance, yeah, between O3 and O4, and on this one is the L3, right? And 0 and D6 is the distance from here to the end point. This is to the end point, right? This is also the end point. Okay, remember this also the end point. This also the end point, as I mentioned. The end point. Okay, yeah. Okay, then the variable is theta 4, theta 5, theta 6. Okay, then this is for gripper, and this is for the the positioning. Then you put them together, then you will have the full DS parameter, DS table of this robot. So remember, this robot, then at the end, you put the gripper at the end, okay, then you will have the table now is 1, 2, 3, 4, 5, 6. Okay, yeah, and you can make the calculation of the full robot, and we follow that approach. Okay, now for example, if you want to put, I will show you. I will show you. So one more, right? Okay. This is just some of the researcher. They want to put the 0 coordinate here. Then they put another one here. So we have the coordinate 7, but the 7 is no variable. They want to put it in this case. If you group this one and this one, this should be L7 here, right? There are sometimes some researcher they want to separate. And that means they don't want to this one appear in the manipulation. They want this one should be 0. So that's one, and that's why they put here 0. And this one is depend on the gripper. You understand? Because sometimes depend on the rich side. So L7 can be different. So that's why they don't want to put that in the robot. When you buy the robot, you just need to make the manipulator with until this point. Okay, from this point to this point is depend on the tune you put on the robot. Okay, that's why some they want to separate this one, and in this case you put one more coordinate is 7. Okay, like that, and the coordinate 6 you put here. Okay, yeah, and of course totally the same, right? Yeah, in the same way, this is the articulated robot, and this is the Stanford or spherical robot. And for this one, you can also do the same. You put here the grids, and you just copy this one. You just copy this one. Just copy this one. Copy this one, and put that into the this you already have 1 2 3 you already have you now you just put 4 5 6 you just put 4 5 6. Okay, yeah, and then you will have the table of this robot. You don't need to do this again. Yeah, and remember, in this case only one thing different. In this case, because the end, I mean the tree, the number 3 joint, or just the forehand. We call that this one. We call this forehand. The forehand joint is sliding. Then you don't need to choose O3 here, but you can choose O3 here. And when you choose O3 here, then you just put this one is 0. Okay, so because you choose O3 here, then this one 0. This is not L3 anymore. Okay, if you put O3 here, the distance from here to here should be D3 or L3. But as I mentioned, in this case you can choose O3 here, so this should be 0. Okay, yeah. So just only that different. So remember, in case of the sliding joint, you can put the O3 here, and this becomes 0. In case of the revolute joint, O3 is the revolute joint. Then you have the joint 3 or the revolute joint. You have to choose O3 here. Then this should be in the DS frame, in DS table of the grid. You should put here L3. Only two cases. Okay, and with that you can do with many with on the robot. For now, you can do for on the robot and please check this one. Okay, this example for the full robot, you can check this table and you understand by your own. Okay, and the next day I will go a little bit through this one. Okay, before we go to further. Okay, it's very clear now, I'm sure, with this one. And you can see this. If you have time, you can do it on, but remember this one, you don't need to repeat this one. This one you just copy from this one. Remember, you copy from this one, then you can put here. Okay, you can put it, you can check. Okay, and you only need to do the first 3 one, and for the crease you just copy and put there. Okay, so you can have like that. And this is also the Puma robot. It's very complicated, and if you understand this one, you understand all of a thing about robot. And the next day I will go with you this one. Okay, yeah. Okay, and this is some other robot like this is a robot for the shutter remote manipulator system for the this is a robot for the space center. Okay, international center. Space center. Okay, it's very long. Yeah, it's very long. Okay, they use to clean the space center. Okay, and of course you can have like this one. Okay, you should do all of this one by your own. Okay, yeah. Okay, and for the next day, I should go a little bit about the inverse, and then say the velocity problem of the robot, and then we can finish. And we have one more chapter. That means about the I just want to introduce one more chapter about the gear system. Okay, so we have 2 days more, and one day I will finish the robot, and I will go with you the chapter about the gear system. That's all. Okay. For the other, you can read by your own, and I will put that in the final exam. Okay. Yeah.
Professor.
Yeah.
As I can see that next week we have class on Tuesday and Wednesday. So can we move to Monday and Tuesday?
Monday and Tuesday. I will check.
Yes. So,
I will check Monday. In that case, how about the whole Tuesday?
yeah, it could be better, but because I want to have more time to practice for the exam.
Okay. I will check, and if in that case for the Monday, maybe we can study in the afternoon, okay, or
Yeah.
evening or something like that. I will check and I will change. Okay. Yeah.
Excuse me, Professor.
Yeah.
Can we have a mock exam to have a better preparation for the exam?
I will do. I will share with you some. The hints. Okay, for the final exam, and give you some. You got some sample exam exam question, right?
Yeah. Some exam question and the homework will be.
Okay, I will share with you that. Okay. Yeah.
Another thing, is CAM design included in the final exam? Because
no.
Okay.
I just very short introduction what is that, and then you don't need to do that in the final exam. Okay.
Okay. Wonderful. Thank you,
Yeah.
sir.
Okay. Thanks. Okay. Bye bye. Okay. See you. I will check the time and will inform you the new schedule, but we try to do everything on Tuesday, right? Okay. That means we will finish everything on Tuesday, and you have more time for preparation. Okay. Bye bye.